afternoon, ladies and gentlemen. Now we will come to our second panel discussion, which is entitled Land and Water Use under Climate Change, from Uncertainty to Policy Advice. So, as you can easily see, the focus is on uncertainty. Uncertainty is important, and put simply, uncertainty is a lack of certainty. And the reason for that can be lack of data or limitation of measurements. We talked about in the first panel about measurement, limitations of measurements, or the variability of situations in time or in space, or the variability of systems in time and in space. Uncertainty, by the way, might also result from too much information. Or it might be caused by unprecise, unclear definitions or expressions. So we have different reasons why we are faced with uncertainty. We are confronted with uncertainty. Uncertainty becomes relevant when we have to make decisions. And that might be a family in West Africa that have to decide to send the children to school. Or it might be a decision maker in, let's say, Bangkok, who has to decide to take measurements to adapt to climate change. So uncertainty is important for everybody. The question is, and that is what I would like to discuss, and probably panelists will contribute to that considerably, how to deal uncertainty. In disciplinary research, in science, especially in the natural sciences, in many cases it is relatively easy. We have statistics, and we describe uncertainty with the probabilities. It is much more difficult in interdisciplinary research. We have different disciplines. All the different disciplines and the research approaches have their uncertainties, and the overall uncertainty might be difficult or even impossible to assess. For example, in research on land and water use under changing climatic conditions, we have field measurements, we have scenarios, we develop scenarios, and we work with models. And all these approaches we apply at the same time. And accordingly, the scientific output is associated with a wide range of uncertainties, which complicate decisions and policy making. So, for me, there are 2 or 3 major questions. The first is how to assess and describe scientific uncertainty. But much more important is how to communicate uncertainty, or how to communicate research results which are associated with uncertainty to decision makers, to policy makers. How to explain uncertainty. And the question is, scientific uncertainty an excuse for inaction of politicians? So I'm curious what we can learn in our 2 brief discussion. Before we start, I'd like to introduce our panelists. I will start with Jakob Rhyner. He is the director of the United Nations University Institute for Environment and Human Security here in Bonn. At the same time, he is vice rector in Europe of the United Nations University. And in addition, he is also ex officio a member of the ZEF Directorate. Then we come to Sennerby Forsse. She is the Vice Chancellor of the Swedish University of Agricultural Science in Uppsala, Sweden. And you joined the ZEF board in 2011, right? Then we have Holm Tiessen. He is on the board for 3 or 4 years already. He's currently the director of the Inter-American Institute for Global Change Research in Brazil. And finally, we have Vera. She's director of the Center for Atmospheric and Ocean Research at the University of Buenos Aires, Argentina. And she also joined the board last year. Right? Okay. So, and in addition, we have a somewhat different format in that panel. In addition, we have 3 kind of discussion openers. That is what we discussed when we planned that panel. That is Christine First, senior researcher at ZEF, a forester and land use planner. We have Jan Werner, who has a junior professorship at ZEF. He is an agricultural economist. And we have John Lammers. He's also an agricultural economist, but for me he is one who has development experience in different parts of the world. So, development expert. Now, let's start with climate. Uncertainty plays a central role in climatology. You work, Carolina Vera, you work on variability of climate, amongst others. And the question is uncertainty in climate-related research a bigger issue than in other scientific disciplines? Which are the causes for that uncertainty regarding climate variability, regarding climate change, of course? And how do climatologists deal with uncertainty? So, the floor is yours.
Okay, good afternoon, everybody. Thanks for the invitation to join both the advisory board and this panel. I have prepared some thoughts that I would like to read in order to keep track on the time, essentially. So it is a bigger issue than in other scientific disciplines. Doubt and uncertainty about our poorer understanding is inherent at the knowledge frontier of any scientific discipline, not only for climate-related research. While extending the knowledge frontier often reduces uncertainty, it leads inevitably to greater uncertainty as anticipated complexities are discovered. Very recently, I read an article wrote by Curry and Webster that appears in the Bulletin of the American Meteorological Society in 2011, that they have discussed the concept about uncertainty monster, in brackets, by an analysis of the different ways that the scientific community responds to uncertainties that are difficult to tame. The monster is the confusion and ambiguity associated with knowledge versus ignorance, objectivity versus subjectivity, facts versus values, prediction versus speculation, and science versus policy. The uncertainty monster gives rise to discomfort and fear, particularly with regard to our reaction to things or situations we cannot understand or control, including the presentiment of radical unknown dangers. Some of the strategies of coping with the uncertainty monster as a science-policy interface suggested by these authors are monster hiding, uncertainty hiding, or the never admit error strategy. Can be motivated by a political agenda or because of fear that uncertain science will be judged as poor science by the outside world. Apart from the ethical issues of monster hiding, the monster may be too big to hide, and uncertainty hiding enraged the monster. Monster exorcisms. The uncertainty monster exorcist focuses on reducing the uncertainty through advocating for more research. However, in the 90s, a growing sense of the infeasibility of reducing uncertainties in global climate modeling emerged in response to the continued emergence of unforeseen complexities and source of uncertainties. Monster simplification. Monster simplifiers attempt to transform the monster by subjectively quantifying and simplifying the monster, simplifying the assessment of uncertainty. And finally, monster assimilation, that is about learning to live with the monster and giving uncertainty an explicit place in the contemplation and management of environmental risk. Assessment and communication of uncertainty and ignorance, along with extended peer communities, are essential in monster assimilation. The challenge to monster assimilation is the ever-changing nature of the monster and the birth of new monsters. Which are the causes of uncertainty regarding the prediction of climate variability and change? There are three distinctive sources. The first is the internal variability of the climate system, that is, the natural fluctuations that arise in the absence of any external forces. Appreciation of this fluctuation is an important matter for decision makers because, for example, they have the potential to reverse for a decade or so the longer-term trends that are associated with anthropogenic climate change. The second is model uncertainty, which means that models are not perfect and in response to the same external forcing, different models can simulate different changes in climate. The third is scenario uncertainty. Uncertainty in future emissions of greenhouse gases, for example, cause uncertainty in future radiate forcings and hence climate. The relative importance of the three sources of uncertainty varies with prediction lead time and with spatial and temporal aberration scale. For time horizon of many decades or longer, the dominant sources of uncertainty at regional and larger spatial scales are model uncertainty and scenario uncertainty. However, for time horizons of a decade or two, the dominant sources of uncertainty on regional scales are model uncertainty and internal variability. How to deal with these uncertainties in the complex climate system and its computer simulation is not simple as obvious. The general approach used by the scientists to represent uncertainties has been to compute model ensemble, which means that rather than conducting a single simulation, multiple simulations are run that sample combination of different initial conditions, model parameters, and model structural forms. Model uncertainty can be evaluated against no analytical solution or against observations. Model calibration to observation is currently an effective way of reducing model prediction errors, and it is usually needed to address parameters that are unknown or inapplicable at the model resolution. However, some scientists argue that instances of fit between model output and observational data do not confirm the models themselves, but rather hypotheses about the adequacy of climate models for particular purposes. In addition, capturing the phenomena in the present climate does not in any way guarantee the ability of the model to capture the phenomena in the future, but it is a necessary condition. Given the inadequacy of current climate models, how should we interpret the climate projection resulting from multimodal ensemble, like for example those using the IPCC assessment reports? The current methods to quantify and partition uncertainty are in general simple and rely heavily on the specific model ensemble, which is currently an ensemble of opportunity. There is a real danger of reducing model spread as a result of tuning and consensus on metrics rather than internal understanding and models. Therefore, the problem of evaluating models and delivering useful uncertainty estimates proved to be harder than expected. It is evident that climate projections are inherently uncertain, and part of the uncertainty related to internal variability is irreducible. Therefore, there might be limits to the potential to narrow uncertainty, but there is no evidence that these limits have yet been reached. The potential to narrow uncertainty is real, and the need is urgent. In addition, acknowledging that progress in climate science may sometimes broaden rather than narrow uncertainty is not a reason to avoid focused attention on the requirement and opportunities to narrow uncertainty. The contribution from internal variability to climate prediction uncertainty is not reducible far ahead, but proper synchronization of climate prediction with observation data particularly should enable some reduction of this contribution for forecasts of the next decade or so. This aspect is currently being addressed in the new generation of climate projections. By contrast, there is a potential to reduce the model contribution to uncertainty for all lead times. New observations, model improvements can be expected to deliver significant progress in this area. However, a serious challenge to improve complex nonlinear models is that model complexity precludes the precise evaluation of the error sources. In summary, science can tame the uncertainty monster by clarifying the confusion and ambiguity associated with knowledge versus ignorance and objectivity versus subjectivity. Nevertheless, doing a good job of characterizing and dealing with uncertainty can never be reduced to a simple cookbook, and that one must always think critically and continually ask questions. I would like to finish with the following advice. We should try and quantify uncertainty where possible. All useful uncertainty statements require judgment and are contingent. We need clear language to honestly communicate deeper uncertainty with due humility and without fear. For public confidence, trust is more important than certainty. Thanks.
Thank you very much. A lot of information, and it was very fast. So, I have a very simple question. Perhaps I missed it, but the understanding of climate change becoming less rather than more clear now?
As I have tried to say, as long as some aspect of the climate system became clearer, new questions arise that you might think about that the uncertainty are increasing. So, yes and no.
Okay, from climate we move to land, to perhaps in land and water. Global change is black with uncertainty, and part of that uncertainty is vulnerability and resilience of natural and of human ecosystems, which includes water and land use. Is climate change the bigger problem for vulnerability, for vulnerable ecosystems? So is climate change the bigger problem? Or is it, are you more concerned about the effects of other human activities like deforestation, groundwater, overexploitation, and others, construction of dams, for example, on vulnerable ecosystems? So is it the climate and the climate change, or is it much more other activities you are concerned about?
Well, thank you for having me here and asking me these questions. You did send me those questions by mail. And I did have something prepared, and then I listened to the last session here, and I threw it all away. And I'm going to start from scratch. I'm a fan of creative chaos, so let me get into the chaos. Whether it was creative in the end, you can decide. The last discussion was on the Millennium Development Goals. And I think climate change is basically an additional risk factor on development. If we treat it like this, immediately we can no longer discuss climate change, ecosystems, separate from development. And I've written down a number of points that came out in the last session, so let me revisit those points and give you examples that hopefully will answer your questions at the same time. First question, is global change more important than regional change? Yes and no. Very simple, very quick. No, but seriously, we heard about hurricanes, typhoons in Asia. These are clearly related to global phenomenon, of increasing temperatures. So if we're talking about the islands in the Caribbean or the islands in Southeast Asia, global change is an extremely critical point. It is also a critical point because many of these islands have very small economies that are seriously disrupted when a hurricane hits. So these hurricanes, in a way, are one expression of global climate change, even though if we will ask the climatologists, there are many non-understood functions in there about sea surface temperatures that are regionally changing versus globally changing, and how this fits together, and that's where the large uncertainty is. Hurricanes is an example of extreme events. So let us think about the incidence of extreme events, droughts, flooding, and so on. And let me give you some examples. We had extreme events last year in Brazil with many people dying and property being destroyed. Basically, massive rains. They're not unusual. I've seen them pop up over the last 30 years. It's getting worse. What was the damage? Initially, when it rains in Rio, the slums that are constructed on the garbage dumps go downhill. It's predictable. It has to do with garbage, slums, and rain. The difference now in the last year was that the rains went a little bit further inland, where the rich people have their houses on the steep slopes, so they have a beautiful view over the countryside. Right on top of granite, the soil over top of granite, saturated, came down the hill. Again, we have, and that's a key lesson there, we have a meteorological phenomenon, but the vulnerability is a social construct. That same rainfall anywhere else, no impact. So let's not forget, when we talk about these risks that are related to climate change, related to regional conditions, related to the ability of ecosystems to deal with climate stresses, that without the social construct, without knowing why something happens to somebody, we don't understand the context. So climate change, global climate change is important. Also in some other regions, and we hear about the poles, and the owner of BMW was taken on a cruise to the Arctic and saw the melting ice, and now BMW is constructing a hybrid car, still with 350 horsepower. But anyway, it's a step in the sort of right direction. And of course, on the continental scale, we have the same thing, global climate change. Where would you look for the impact? At the snow line, at the snow and glacier line of the Andes. These are retreating. Many of the tropical Andes glaciers have disappeared. And who depends on that? Bogota, the water supply of the city is almost entirely derived from snow melt and glacial melt up in the Andes. So when we look for vulnerabilities to global phenomena, we need to go into these marginal areas, dry areas where an additional drought will have major impact, high areas where the frost line advancing or coming down by 100 or 200 or 300 meters will have a major impact on downstream communities and downstream ecology. If we then go into the big plain areas, like the North American plains, but now the development pressure is in the La Plata Basin. In the La Plata Basin, global climate change, to my understanding, is irrelevant. In the effects that we see that have major impacts, it's the local changes that count. It's the 30 million hectares of new agricultural land that we have created from native vegetation and from pasture vegetation over the last 25 years. Now, think about this. If you go out there and look at, or feel, just walk across the field, feel the temperature in the forest, feel the temperature in the field, feel the wind, feel the moisture. 1 or 2 degrees, 3 degrees difference, 5 degrees difference is nothing particular. The global change is 0.8 degrees. So these 0.8 degrees in that context are totally irrelevant. And what we're seeing now is that there has been enough land use change across the La Plata Basin to change the climate system. And again, if you're familiar with climate models, you will know that climate models are very often driven by sea surface temperatures. And when we look at these models, intuitively we understand that a 1 or 2 degree difference in sea surface temperature can have a tremendous impact on the climate. And we accept that. because the scientists have been telling us that for 20 years. Now we see a 5-degree difference in the land surface temperature and in the wind patterns over a total of 30 million hectares on the continent. Now the new models that we're running for Latin America tell us the regional climate change that is being created locally by local land use decisions is affecting the climate over Antarctica. So we're seeing local to global or local to continental feedbacks that are totally new and that are changing the science of climate modeling. That, by the way, brings me to the millennium scenarios, and I think they're totally inadequate. They are a wonderful tool, they have been a wonderful tool in terms of constructing a discussion and bringing this into the political mainstream. But when we're dealing with these regional impacts, they are quite inadequate, and we need to really start things from the bottom up. Take the example of Colombia. We heard about drugs. Colombia is a very peculiar country right now in terms of ecosystem function and in terms of the way the regional hydrology functions. Why? Because of drugs and because of political unrest. Because the farmers who were out there managing the land over the last 30 years have left their land, abandoned their land. That has changed the hydrology of the valleys and the vegetation in the valleys totally. And now, after 30 years of war, the Colombian government is dealing with the opportunities and risks of resettling these areas. We may hear about property disputes as to who was there and who's there now and so on and so on. But there's also a huge environmental impact that is almost on a countrywide scale that deals with what do we do with land that was abandoned for 30 years and now is being taken back into some kind of use. How do we regulate this? How does policy deal with this? What are the decisions that we should be taking? So these are just some of the examples, and if I was to give you a bottom line,
I would like to bring it back to uncertainty.
The questions that you asked me were not on uncertainty, but anyway, if you bring it back to the bottom line, the uncertainty that we hear about in the climate is modified by social processes, by political processes, by social constructs, and that brings us back to, if you want the word uncertainty in there, to the uncertainty that the politician has to deal with when he takes a decision. Nobody could predict the course of the war. Nobody could predict the economic development or the way the drug trade goes in the region or the way the soybean price goes. And these need to be factored in. And these are uncertainties, by the way, that the politician understands better than the scientist. So we need that dialogue.
Let me add briefly another question. You personally, are you more concerned with uncertainty with regard to global change or with a lack in understanding the processes leading to that change, or with a lack of data available? What is more important for you? Is it an issue, uncertainty?
Well, the message I was trying to get across is that you can't answer that question. Because the global political system and the global decision-making system at the IPCC level, at the United Nations level, does not work. It will not. What we need is the implementation in the region, and the regions have different uncertainties. And sometimes they have certainties. We know I can predict what is going to happen in the La Plata Basin over the next 15 years if the soya market remains the same way it is right now, and it will, because the Chinese want the soybean so that they can feed more chickens and more pigs. This is perfectly predictable. The uncertainty comes in totally different randomized patterns, and the answers to that are local and regional and not global, and are not the uncertainties that Carolina is talking about, but the uncertainties that arise out of the context, which is variable from region to region, from country to country. I could go deeper and compare a common region in Paraguay and in Argentina, same ecology, same hydrology, different political system, and the uncertainties and the reactions you need are very, very different. So you need a much stronger bottom-up approach in the science. And that's it.
Yeah, perhaps there's another question, but now we have to come to our next panelist. Holm made an interesting example that was that the problem with the slopes in Rio, that it is predictable what will happen. It is predictable, but we don't know when it happens. And that has to do with risk. And risk brings me to the next panelist. Recently, I read in the papers that United Nations University, EHS, developed a world risk index. And you might know that uncertainty and risk are closely related. World Risk Index. It is calculated for individual countries, and you published it a couple of weeks ago with your partners. How did you assess that country-specific or these country-specific risks related to climate change and combine them with the country-specific, again, vulnerability? How did you cope with that risk factor, with that risk index, with uncertainties? I mean, you calculated for countries, so the uncertainty, what Tiessen said, might be, yeah, even not possible to assess. I have seen in that report that Vanuatu and Tonga are at the end of the table. So should we avoid, based on your assessment, should we avoid Vanuatu and Tonga and should move to Qatar and Malta because they have a relatively low risk index? Okay, it's your turn.
Thank you, Manfred. First of all, let me say that you should continue to enjoy to Tonga and Tuvalu. Actually, we published this World Risk Index, or we developed the World Risk Index 1 year ago, and just reused it this time, so we recognize that we can get famous twice with this. But let me put this into a bit somewhat larger context. I will try to be short. Risk analysis is really about trying to find out where people get hurt, where change and events get really hurting. Change in itself, whether it is climate change or other change in itself, is not a problem. Not even natural hazards in themselves are a problem. They are a problem when they meet vulnerable people. I think when you go to the Colombian mountains, then you see this vulnerability because these regions have been abandoned. When you go to the European mountains, you will see that people have a tremendous exposition to natural hazards. However, the risk they're living in is not particularly large because they're not vulnerable. So what we are trying to see is how this vulnerability, what the dimensions of vulnerability really are. And we try to factor in this World Risk Index, we try to factor them along 3 dimensions. I will be very short and not go into definitions. The first one is susceptibility. The question is, when you have an earthquake, do you live in an earthquake-safe house or not? The second one is coping capacity. When you are hit by an event, can you expect someone to help you? Are you evacuated when you should be evacuated? And the third dimension of vulnerability is the coping capacity. Can you expect someone to help you not to be hit again by the same event in the same manner in future? So when we're looking at these 3 dimensions, and we really try to be courageous enough and try to put them in simple numbers, combining 28 indicators. And I will come back to this. When you're doing this, you're always vulnerable yourself afterwards. What we see is that there is people in many countries are living in is not determined by their exposition to natural hazards, but it is determined by vulnerability. So it's not climate change in many cases they have to worry about, but it's problems they have that no one supports them when they're hit by an event, or that they are hit 10 years later again in the same way by the same event. Maybe having learned lessons, but not having the support to transfer these lessons into practice. So this is very much going about your lines on that. In many cases, it is not climate change what really hurts people. In other cases, it may be. I said there are 28 indicators which went into this report. Do we have uncertainty? Oh yes. We have the uncertainties Carolina talked about. The question is how everything which we calculate for now is developing until tomorrow. Combining 28 indicators is highly debatable. We try to document it as well as possible how we did it. You have to admit that sometimes you're comparing apples with pears. Any future projection has its uncertainty. So yes, we have a lot of uncertainty. My message is twofold. First of all, don't be afraid of uncertainties. It's the most normal thing every one of us has in planning. The conclusions which we have to make robust. Try to be as robust as possible in view of uncertainties. In many cases, uncertainties may really hit us, but there are many examples where we have uncertainties, but the consequences we have to think about are very robust against uncertainties. For example, I had a very interesting talk by an African colleague, a hydrologist. He told us in a talk that when you look at the climate models, I don't know about the numbers, maybe these can be contested, but he said that only in 3% of the regions in Africa, the climate change models and different scenarios are agreeing even on the sign of whether there will be more or less water. He asked the question, does it mean that we don't know what to do? And his answer was, oh no, we know precisely what to do. I will not give the answer, we can discuss it afterwards. The second message I would like to give, however, and this is usually a message that is given by scientists to politicians, I would like to give it to the scientists as well. Don't take uncertainties as a reason to propose, not to propose and to take actions. I think we are scientists, we are, as well as politicians, we are obliged and forced to try to see what can be said, what kind of robustness we can reach in our statements and make them. This is what we try to make in the World Risk Index, by the way, knowing that there are many reasons why you should not do it yet, and you should try to wait for another 100 years until you make a prediction based on a better assessment. I think we can try to reduce, and we should try to reduce uncertainties, but they should be a real integrative part of the work we do as scientists. So much for it.
Thank you. When I started to introduce that panel and the discussion and the title, I mentioned that communicating uncertainty is important, and the question is how it can be communicated. I think, and it was mentioned already, of course, scientists have to work together with the target groups, with decision makers, with practitioners, and so on. The newly developed international program Future Earth, Research for Global Sustainability, which will replace the other 4 old global change programs, for instance, suggested that research agendas should be developed in a process they call co-design. So researchers together with users of scientific information, not only researchers and users, but also the funders should be involved in setting up research agendas. Which role plays the collaboration, Lisa, between researchers and practitioners at SAU, the agricultural university in Uppsala? And what are the major obstacles when establishing science-practice collaboration? And perhaps finally, and that is, from my point of view at least, a quite important question. If we realize that co-design, that researchers and the users of research or scientific information have to work together, is that a loss of academic freedom or of the autonomy of science? Yeah, the floor is yours.
Yes, thank you very much. And I'm happy to be here and to be part of this panel, of course. I've heard about what my colleagues have said here about the uncertainties in research. And let me start by telling you about an investigation that was made a couple of years ago, and it was renewed this year, telling us that confidence from the public in research and scientists is steadily going down, People does not rely on what scientists say. And this is, of course, a bit worrying. And you might ask, why is that? Well, some of it I think we heard here, and that has to do with uncertainties. And researchers would like to be quite safe when they communicate their research results. They always talk about probabilities. They're telling that this time, this result from this study, during these circumstances, showed this results, but, and then, so what should people think? And then we have a lot of other groups in society that are very sure of how things are. And they can tell people, this is the way it is. And many people don't like uncertainties and would like to have, the answer. You can find it in religion, you can find it in tradition, you can find it in all different ways. So this was just a little parenthesis. The questions you asked me was, how are we working with this at SFU University? Well, for us being a sectorial university, we have a broad variety of scientific areas: agriculture, forestry, veterinary medicine, environment, livestock management, things like that, plant breeding, from basic research to very applied research. We work a lot with the sectors. We work a lot with the practitioners, with the farmers, but also with the sectors and with the research parts of the sectors that we are involved with. And they don't give us much money, we don't do it for money, but because this is our role, this is our sector, and the researchers are interested in problems and possibilities in our sector. And we do it because we feel that we need to keep up the dialogue with the other stakeholders in these areas. And the dialogue is about what are the most urgent problems that we should deal with. And we can tell, when they tell us, when the stakeholders and people tell us, this is the problems, these are the problems, please solve them for us. We can tell them whether research is the right way to go, or whether you should solve it in some other ways. And this I have learned, and we have seen many, many times, that it has a very important role to play when it comes to trust. To trust the scientists. Mistrust can easily arise if the distance is too far. We also learn to speak the same language when we have people involved from the stakeholders. So it is, for many reasons, everybody, it's a win-win situation to work closely with the stakeholders and the practitioners. At the same time, it's not easy. It's not easy to actually work together with the practitioners. So you also asked me, how are the ways that we are dealing with this? Well, besides the continuous dialogue that we have with them, we also have management meetings on a regular basis. We meet the leadership of the industry, the leadership of the different organizations, governmental and other NGOs, on a regular basis. We discuss what are the problems, what are the signals, how do we see the trends coming and going, and so on. We also have, like you have here, an advisory group. We have advisory groups in the different areas of what we are doing. We have co-funding of different projects from industry. We have PhD students paid by industry coming to us to be educated and going back to industry. They come with a problem and they learn, they have the theory with us, and they do their scientific work for the industry, so we do this together. The major obstacles when establishing this is communication failures. That's where the real difficult thing is, to communicate, to get people to understand, to get the researchers to use the language and to themselves understand where are the vital points that I need to reach in order to get this person to understand what I'm saying and what I would like to do. And this is something that we have to learn. Both sides must learn this. One way that we are dealing with it, more concrete, is that we have established a new kind of academic position. We call them extension lectures. We have installed 20 new such academic positions. They are researchers. 50% of the time they do research in an area. The other 50% of the time they have the responsibility to be the contact point for the sector for these type of problems and questions. And it's not only their own little narrow field, but they can take a larger part of that field. That could be, for example, in energy, it could be in plant pathology, it could be in soil science, different aspects. And this is one way of establishing a better contact with the actors outside of the university. This is, of course, one way of doing it. And then you have the communication that is done on a regular basis by seminars, by publications, by not only research publications, but also publications that are summarizing. And I think one message, everybody has given a message, I have to give a message as well. And I think my message would be that we as researchers, we need to do more synthesis work of what we are doing. We need to get together, and when we have themes, for example, we have a program that we call Future Agriculture. It's an interdisciplinary program under an umbrella, and we have different sub-projects in that. In the sub-projects, the researchers work together with the practitioners and stakeholders in the different areas. And in the frame of this Future Agriculture program, we have a hub, the hub for synthesis. That's where the researchers come together and talk about their results, talk about their research, and sit down and try to make synthesis of what has come out. It could be a synthesis of the problem. It could be a new definition, a broader, to define the problem out of the different definitions that is already there. And I would say that this is, you know, cooking by creativity, these camps. Everybody is quite excited right now. We see how long it lasts for, but right now it's a new idea and everybody is quite happy with that. Your final question, I think, was if that would have an impact on the academic freedom. No, it won't. Okay, thank you.
Thank you very much. We don't have yet a time problem. Not yet. You had 70 minutes. So, yeah, as I mentioned in the beginning, we have three kind of discussions or discussion openers. Christina, you work a lot with land use planners, with the authorities, dealing with land use plan, resource planning. What is your experience with regard to uncertainty? And do you have a question to our panel?
My experience, very bad. Uncertainty in practice is something very horrible, and of course I have a question if I'm allowed to give one. So, at the moment I'm working on a research profile for a virtual land use institute, which is European-wide, and I got a nice impact from a colleague at Joint Research Center in Iskra, and he says, okay, we have so many research on ecosystem reactions, on climate change and how it impacts resource provision. This is by far enough. But what we do not have so far are agreed approaches on regional development planning that help us fighting unsustainable land consumption, land degradation, land grabbing, and also land abandonment. This is one of our biggest problems, to break down the policies, the policy advice, to practice, to spatially explicit decisions what a piece of land should provide in the future. And then we have this uncertainty, this monster. I like this, this idea, this image very much. But this monster does not only come from climate research, but from the future of society, from the demands in resources, from the demands in services, and from their consumption. And consumption is maybe even a higher uncertainty than the demands. So, I would like to ask Holm, Tiessen and Caroline Vera about a fifth strategy of monster shrinking from dragon size to crocodile size. This means how can we narrow down uncertainty in a meaningful way for land use planning, for regional development planning, within the degrees of freedom we have in planning. I heard it from you, we do not have the degree of freedom to put people away from risky sites. So how can we narrow down uncertainty without losing the confidence of society? And the next question is to Lisa. Two questions. Is to Lisa. I like very much your approach of research, of communication with practice. And what came to my mind is, can we even think about more integrative research approaches where even practitioners are invited to contribute to a part of research, to do maybe own research to help us to really provide them with the results they can work with?
Okay, before you answer, now I have to be more rigid. Please, short answers.
Okay.
It was a long question, but a short answer.
Yes, I will try to make a short answer. My answer would be to put the real problem in the middle. And the problem is, as Holm says, is the climate-related risk reduction. It's not the climate itself. I think that in many regional programs have made progress on that, and particularly the last IPCC report on extreme events, that was something new, that the center of the program was disaster risk reduction and how climate and variability and change can affect that. So if you start to think the problem out from that, I think that the uncertainty will have another perspective. Sorry, but I'm not good being short in English.
Oh, that's fine.
I think the fundamental problem is what you said. Society is looking for certainty. We're going in a fundamentalist route. in the search for certainty. And scientists are on the other side. We need uncertainty because the corollary for uncertainty is that more research is needed, which pays our salaries. So that is the crucial point that we need to address. So the solution to the better land use planning is in a dialogue between the users of the land and the scientists, because the scientists in reality have many of the answers already. The problem is how to communicate these answers, how to apply those answers, and then there's still enough in the pie to also do some research, but the communication problem, I think, between this wanting certainty and wanting to sell their uncertainty because their career depends on it is the crucial point.
Okay, yes, I didn't say that, but actually in our future programs that we are working with, the practitioners are part of the research. So they take part from the beginning. They are there when we define the research questions together with them. And then those discussions take place before the actual research project is defined and you know, the application can be sent in and so on. And then they participate at different stages. Of course, they don't do the measurements and the data collection and things like that, but that's okay because they know what would be done. So they are confident that this is part of, you know, they are part of it as well. So we do that. Yeah.
Jan Börner, you work on policy advice in the Amazon region regarding forest use and forest conservation, and I know that you have prepared a question. Hopefully just one.
More distracted as well. We talked about the policy science dialogue a little bit, and it occurs to me whenever we write proposals, we sort of assume that policymakers want to make a socially optimal decision and propose solutions and recommendations on how that could be achieved. But then, more than often, I sort of experience that policymakers sometimes want the most politically convenient research result, which is often not the most certain one. So politicians make very bold decisions, and have to do very bold decisions. So my question is, should we work more in terms of understanding what can be done politically, and then sort of design our recommendations more in that realm of policy making, or should we stick to the old way of doing it and try to really come up with an ideal solution, which then often doesn't have a politically feasible way to work?
That's a really tricky one, but I think we're converging. If you look at the IPCC, if you look at much of the global change research, that was initiated by the politicians. It was the political side which was suddenly getting worried and said, hey, scientists, you have to look at this and give us the answers. The IPCC was not sui generis out of the science community. It was a response to a political question that was being asked around the globe. So we're already getting a little bit into this exchange that helps. And as with everything else I said, it's a chaos, it needs solutions that are negotiated on the spot, like every policy that depends on which party is in power right now and who will be next and so on. The same thing is with this science policy dialogue. There is no recipe. You have to see, the scientists have to learn what is politically acceptable of what I can offer from my science, and live with the frustration of your science not being accepted. This is one, if I have half a minute, we had one project where people looked at the gradations of primary forest, secondary forest, and so on, to help legislators decide which of these forests should be protected by law and which should be cut down or could be cut down for agricultural use. Their recommendations were thrown out, and the scientists were really sad, really disappointed, didn't want anything to do with the political dialogue anymore. And I said, well, your science was perfect. The problem was you were not able to communicate to society, to lawmakers, why you attach a value to ecosystem services that you see in a certain level of ecosystem. That is the only problem out of this story. So address that problem and keep doing it. So it's a to and fro in development.
Thank you. John Lamas, now it's your turn. I know that you want to redirect in a certain way the discussion to ZEF. Is that still true?
Yes, I will still try to, especially because in the first panel it was mentioned that the research should be done before and not after. When I look at some of these monsters, they are existing. And so the question comes up for an organization like ZEF, small compared to very specialized research organizations with lots of funds and creating a lot of uncertainties to make certain that salaries are streaming. What is the comparative advantage of ZEF to jump on that bandwagon? You know, should we go for the monster because it brings a lot, or should we try to focus a little bit on finding a lot of good methods to hide the monster and give that as an advice? So, especially in the view of this uncertainty, is it worthwhile going for this kind of monsters, or should ZEF, or what are the comparative advantages of ZEF? Some words of wisdom on that for the future.
I can make a comment on that, probably others of the panel too. I think that I would like to link two things for your question. One is the fact that climate is not the only uncertain portion of this story. And the other, and so there is a need to integrate or to combine the different sources of uncertainties. And something that was said before, that is the only way that it seems to be successful is to do in partnership with not only among research of different disciplines, but also with the different practitioners and decision makers. And so ZEF is already an integrated institute, and maybe so you can tackle easier than other, as you say, that are a focused research institute. You are in better position to do that. But still it's a challenge, because there is a issue in the dialogue. What means uncertain for each of the actors? But I think that compared to other institutions, ZEF is in better condition to start or to improve that dialogue than others.
I think, to paraphrase Lisa's comment, the answer is synthesis, and synthesis. You have the position here of bringing the different disciplines together and being able to describe the monster in a better way and in an understandable way. And your principal challenge in that will be to be able to do the synthesis without losing disciplinary depth and reliability. That is the key problem for ZEF. You're on the right way in providing the right products, and you need to check in the rear view mirror to make sure you're not losing the disciplines while you're doing this. And I think that summarizes what you need to be thinking about.
Lisa and Jakob, do you want to comment on that?
No, I think that was wisely stated, and I really think that is the right way to go for ZEF as well. And I will also say, as was said before, that it's not very easy, but it's worth trying, definitely.
I think some of these monsters, I think you can handle by doing what was shortly touched upon by Holm, which I very much support. That science, I think, should go one step further in really not just providing the so-called scientific evidence or non-evidence, and then let the politicians do something and talk badly if they don't do it. I think we should take a step further, going into the policy engineering, looking at this as an integral part of the scientific projects. And I will go even one step further. I think we should also help to develop business models for the transfer of our ideas into practice. And then we encounter some of these monsters, but not as monsters anymore, but as part of the questions at hand, actually, not just something being outside and not being influenceable, and I'm afraid that when we're doing this together with the practitioners, this will maybe put our so-called academic freedom a bit on discussion. I'm a bit provocative here. I don't think it puts it in on discussion with respect to the scientific quality. This has to be our domain at all. But with respect to choosing and defining the themes we are working on, we really should let practice in and take part in this decision. I think you do it at your university to a lot of extent. But I think we should not be afraid of kind of scratching a bit at the academic freedom when it comes to defining the themes.
I could also say that it's easier to get money for the research if you have someone asking for it. So that's also something to think about.
Okay, so we have 10 minutes roughly. The audience has to be active as well, so you ask questions.
I thought we might bring in a bit of social science into the science. And it seems to me from that perspective, perhaps too much is being made on uncertainty. I know economists have very bad reputation, especially since the financial crisis. Nevertheless, we do know that there's a degree of predictability. Take land use, for instance. Prices do make a difference. The extent of subsidies make a difference. How much America moves its land from maize to biofuels is affected by the extent of subsidy for biofuels. So to say that it's a monster, it seems to me, is really overstretching it. And I would like the panel to bring in the first bit of the title, land and water use, and how policies could be framed in order that land and water use is more rationally used and can affect, deal with issues of climate change, mitigation, adaptation. And I hope that, perhaps Lisa could also say something on food security questions since you're from the agricultural sciences, because we know climate change is going to be hugely affected by that. Now, it was touched on a little bit by Holm in terms of land use. But could we be more specific in that respect? And just one final aside that, our lifestyles make a huge difference. So for instance, IFPRI had done a study which showed that if you if you reduce the amount of meat consumption in China and the OECD countries by a certain proportion, it would save not just the feed, but also the land use, and could make a big difference to food grain production for human consumption. So some of these ideas could we hear a little bit more about that as well. And similarly for water use. In the first panel, somebody had talked about water pumps. Now the fact is that groundwater is going down because there's very little cost to overdrawing of groundwater for deep tube wells. It's not the pumps which matter. We're hitting the arsenic level because we're overdrawing the groundwater. So the three elements in that panel titled Land, Water, Policy, with a bit of economics thrown in with that.
I was wondering, considering ZEF's role, whether there wouldn't be certain places on Earth, if you will, with this topic, where you could take a bit of a catalyst role or prepare for it through the scientific research work you do. Let me use the example of Amazonia. I lead the program Amazonia in Sao Paulo at the university, and we ran workshops 2 years ago on water management in Amazonia. Amazonia is the largest freshwater system on Earth. But when you look, it's so many countries involved, and it's really very poorly, both in terms of science, research, not enough budget, quite simply, and not enough integrated thinking, while climate change on the oceans and through deforestation continues. So these are very important topics. They are far too big for ZEF to handle, quote unquote, but an outside of a region, in this case, institution, would maybe just be the right place to help with certain discussion and thought processes. Just a thought.
Paul. Yeah. Yes, I'm coming back to the question that I asked earlier. There is not too much uncertainty in Niger, a country that cannot feed itself at home, with a birth rate of 3.5%, that the options for land use and water use are extremely limited and getting narrower and narrower. Do you as a panel see that in this diagram that we have, land use, biodiversity, water use, sustainable energy and health, that we're missing the other side of the equation, which is, if it is indeed for the next 25 years, 3.5% increase in population of Niger, all of this discussion is relatively useless. No matter which climate we will have, no matter which land use policies we'll have. And this is not only in Niger. I use Niger as an example. There are many other countries where we can apply this. So I'm a little bit concerned living in Africa and seeing this happening around me, and I'm wondering whether we are missing the boat.
So that was, these were three comments / questions from your side, yeah? Yeah.
Yeah, it's just maybe not answers, but comments to two of the questions. First of all, they're useful. Last year, I had the honor at the COP18 in Durban to present the report which we had written together with UNEP on the connection between climate change and migration in the Sahel zone, just as a kind of a first assessment, knowing that the data are yet very sparse. And there was a statement that the strong growth in population is even exacerbating the problem. At the end, after all discussions, I had the feeling that we had formulated it the wrong way around. I think it may be climate change that is exacerbating the tremendous problem of population growth. So this is an example where the mainstream discussion can even has even the danger to frame the problem in a wrong way, maybe. So that's one of the comments to your question. The second, about social sciences. I most fully agree that natural science and engineering will not solve the problems we are discussing about. I'm quite strongly involved in these future Earth discussions, Manfred, you mentioned. And there we are discussing a lot about another elephant in the room, namely behavior and values. And I think social science might try to contribute to a kind of reframing values. There is for me a courageous example, an encouraging example with our behavior with respect to smoking. I don't want to insult the remaining smokers, but even against the strong industry, there has been a strong change in the attitude, at least in some parts of the world. So I'm wondering if this cannot be reached with meat consumptions or with fuel consumptions. Just let this question open.
Okay, just a few words about food security, food production, the need for increased productivity. We had yesterday an inauguration of a new unit at the university called SMU Global. And there is a big meeting going on for 2 days with people from all over the world. And many of your colleagues, you would know them from ZEF. The discussion was very much about the increasing gap in countries that are growing. Growing economies now, growing middle classes is a more and more strong group where we can see how the demand for feed, for milk, for meat is growing very, very much. And it was also several people that lifted the issue that poor people are found today in the developing, not the developing countries, but in countries that are growing. So it's not poor, it's not only in the poorest countries, in the developing countries, but you find poor people in countries that are really having a very rapid economic development right now. So the complexity of the food security and food production is getting even more complex than before. So you can't today divide the world in developing countries and developed countries, but there are a variety of different countries that have a different, there are the different levels of development. So this is just my reflection on how complex the situation is today, and that you really have to see, I think it was said before, we have regional and local differences that we have to look at in order to solve the problems. And we can't do it on the global level. We have to see what are the obstacles, what are the conditions, what are the premises in every place in order to do that. And that also goes for Paul's question. I think you have to look at it in every place to see what can be done there. And finally, I would definitely say the same thing as you, that we need social scientists, definitely, in our interdisciplinary programs. They are not there yet in the way they should be, but I think they are on their way. So I think we will see them coming.
I got a sign that we have to come to an end, but I promise that, 3 short comments on questions are possible. That is Tobias, that is Mike, and that is Konstantin.
Yeah, just a small comment. There is a nice statement in the Stern review on climate change, and it says something like that for good climate change adaptation, governments should do what they are supposed to do anyway, so better infrastructure, education, governance, and so forth. So at least to that extent, uncertainty about climate change doesn't really matter so much. It shouldn't keep governments from doing what they're supposed to do.
Yeah, thanks. Thanks. I only want to comment on the metaphor of the monster, which I have to admit I didn't like too much. It was put forward by Professor Vera, I think, and it was taken up then by the other panelists. And I only wanted to say that perhaps, Professor Sennerby, Forsse, what you mentioned, that the trust of the public in scientific work may be related to such type of metaphors. Because, well, as you said yourself, other disciplines or other branches of the society may have answers to this, and scientists may create through such metaphors perhaps actually the mistrust of the public. Okay, that's all.
Okay. We need the micro here for Konstantin. It's the same. Okay. To close, I have 3 short comments. The first is, according to our discussion and what we have heard, the first is uncertainty is certain. The second is scientific uncertainty is no excuse for political inaction. And the third is, and I also like that image of a monster, and I think that the audience here will have an image in the future of a tamed monster now. Okay, thank you very much. And